Alright, Physics Fridays, let's do another practice problem. In this problem, we have a sphere with a diameter of 32 centimeters and a mass of 45 kilograms. And the sphere is being supported against a wall by a 30 centimeter wire. And the problem wants us to find the tension in that wire. And as always, before we get too freaked out by all the text, we want to draw a quick picture to better visualize the problem. So we've got the ball against the wall there, and I'll just label a few things. And before we get going with anything else, I want to find the angle that the wire makes with the wall. And we can do this pretty easily with some trigonometry knowledge, that the sine of an angle is equal to the ratio of the opposite side of that angle and the hypotenuse of the triangle that's being made. And we can plug in the values of 16 centimeters for that opposite side of the wall, which is the ball's radius, and 30 centimeters for the hypotenuse, or the length of the wire. We can simplify our picture a bit by turning it into a free body diagram, so just looking at the forces acting on the system, where we have the tension of the wire, the weight of the ball, and the normal force acting on the ball as it's pressing against the wall. To find the tension of the wire, we can just consider the y components of the forces acting on this system. For the y components, we have the y component of the tension, which we can isolate with a little help from cosine, and then also the force of gravity acting downwards on the ball. And plugging in some numbers, we find that the tension is 470 newtons. There's a second part of this problem that asks, how hard does the ball push on the wall? And there's a trick to this one, and we just have to remember that the normal force is what represents the reaction of something pushing on something else, in this case the ball pushing on the wall. So the value of the normal force is our answer for this part. And we can solve for that quickly by just plugging in for theta and t, tension, which we have from the first part. Well, thank you for watching, and let me know if you have any questions or thoughts about this problem.